Hi, Algebra 2 students. Today, our goal is that we can write a transformed equation based on a graph or a description. We want to translate this parent function to create a new function. The parent function is y is equal to x squared. We want to be able to go right, 4, up to, and a vertical shrink of 2/3. Now, in order to do that, ladies and gentlemen, we want to think about what's happening. So we have this parent table, okay? And we could fill it in. I'm not going to fill it in, but we know that we have this parent graph. Here's my x and my y. And that parent graph looks like a nice U. And I'm sketching that so it doesn't look the best. So what's happening to go right 4? Well, what's happening to go right 4 is I'm moving in the x direction. So on that table, when you guys were practicing it, we were adding 4 to the x values. Now, what you need to remember, whenever we are dealing with the x values, that was happening inside the grouping symbol. Okay, that was happening inside the grouping symbol. And whatever was happening inside the grouping symbol, we did the opposite to x on the table. Okay, whatever was happening inside the grouping symbol, we did the opposite to x on the table. So let's go ahead and let's rewrite what we have. So we have y is equal to my grouping symbol, now x minus 4 squared. Again, going right 4 on my parent function means I added 4 to my table when I was graphing that earlier. Okay. Next, let's talk about this up to. Well, up to means I'm going up in the y direction. And so on my table, what I would have done is I would have added 2. I'm going to put it up over here for a reason, and I'll talk about why in a second. Okay. So whenever we do anything to the y, well, that was happening outside of the grouping symbol for that function. Okay. Again, outside the grouping symbol for that function. So that's going to happen over here. I'm going to add 2. Again, why am I adding 2? Because I went up 2 based off this description. That means I'm adding 2 to my y's. And that's outside. So inside is to the inside the grouping symbols to the x, and that's the opposite operation, which we see right here in green. Outside is to the y. Next, we have a vertical shrink of 2/3. A vertical shrink of 2/3 means we're multiplying this y value by 2/3. Okay. Again, y is outside the grouping symbol here. Okay. I'm multiplying that on the outside here. I'm multiplying that group by that grouping symbol. So y is equal to 2/3 times x minus 4 squared plus 2. And there's my final function. Let's keep practicing, you guys. Okay, the next one we have this square root of x. Again, what does the square root of x look like? Just so you have a picture in your head. Here's just a sketch. Again, I'm using my mouse at home, so forgive me, it's not the perfect sketch. Okay, now what it says reflect over the x-axis, horizontal shrink by a factor of 1/3 and up 9, okay? This one is a little bit more difficult. Let's think about what's going on. A reflection over the x-axis. A reflection over the x-axis is happening to the y values. What that means, ladies and gentlemen, is let's actually fill out the parent table here. So the parent table for the square root of x is 0, 1, 4, 9, 0, 1, 2, 3. A reflection over the x-axis means all of these y values here now turn to negative values. It reflected over the x-axis. Okay, so all of these just turn to negative values with the exception of 0. How did that happen? Well, a multiplication of -1 had to happen to that. Okay, so that means I need a negative on the outside of the grouping symbol. So I'm going to start off in blue. Y equals the negative square root of x. That took care of this reflection over the x-axis. Now it says we have a horizontal shrink by a factor of 1/3. A factor of 1/3 means we're dividing by 3 to the x's. Why do I know to the x's? Because I said horizontal. So the x values now are now shrinking up, okay? I'm dividing by 3. How did I know that? A horizontal shrink by a factor of 1/3. Okay, that means I divided all of these x values by 3, or I multiplied it by 1/3. You can think of it that way as well, okay? Well, anything that happens to the x values means I need to do the opposite to the inside of the grouping symbol. Again, opposite to the inside of the grouping symbol. Well, what's the opposite of multiplying by 1/3? That would be multiplying by the reciprocal 3, or the opposite operation of dividing by 3 is multiplying by 3. So inside my grouping symbol now I'm going to put y is equal to negative, and I'm going to put it in green so I can color code it here, 3x. And now I've just taken care of that horizontal shrink by a factor of 1/3. Finally, I want to talk about going up 9. So up 9 is we're going up, so that's in the y direction. I'm adding 9 to all of my values here. Anything that's happening to the y is happening on the outside of the grouping symbol. So I'm going to add 9 over here. And here is my final answer. Let's keep cruising, guys. Let's keep practicing more. We have the absolute value of x here. We have a vertical stretch by a factor of 5. We're going to reflect over the y-axis, and we're going to go down 7, okay? So let's think about, again, what's happening here to this table when we talk about this description. A vertical stretch by a factor of 5. So what does that mean? Okay, here's my parent table, just a quick sketch of it. A vertical stretch means I'm stretching in the y direction. By a factor of 5 means I'm multiplying the y's by 5. Anything that's happening to the y value, okay, happens outside of the grouping symbol, okay? And it's the same operation. So I'm going to write this as y is equal to 5 times the square root of x. Times the absolute value of x. Okay, that is giving us a vertical stretch by a factor of 5. Now to reflect over the y-axis. Anytime we have a reflection, we're going to have a multiplication of a negative. It's either going to be on the outside or on the inside, okay? On the outside or the inside, and it is going to be opposite, okay? So what's happening then is I have a negative inside the grouping symbol. A negative inside the grouping symbol, that's going to give us a reflection over the y-axis. So I'm going to multiply by -1, or technically it's actually going to be a division of -1, okay? Why? Because if I look at this now, I'm going to have y is equal to 5 times the absolute value of x, okay? And then I'm going to put in red to color code a negative here. This is a multiplication of -1. On our table, remember, we do the opposite operation to the table. So a multiplication of -1 means we'd be dividing by -1. Okay, we would be dividing by -1. You're going to get the same, whatever. It doesn't matter. It does matter, but I'm sorry, I said a multiplication to begin with. So we're going to have a negative right here on the inside. That's going to give us the reflection over the y-axis. Okay, finally, we need to go down 7. So that means down means we're going in the y direction. So that's on the outside of the grouping symbol, because going down 7 happens to the y. Okay, going down 7 happens to the y. So -7. And there we go. Let's keep practicing. Now we have a cubic one, okay? A cubic one. The cubed root of x, right? We have the cubed root of x. So what does this look like? Just as a review, as just a quick sketch, the cubed root of x looks like this, okay? Again, if I was going to graph this, I would have an x and a y. And let's read what our new description is. We want to reflect over the x-axis. That means our y values need to flip-flop, okay? My positive values need to go negative. My negative values need to go positive. Again, in order to reflect over the x-axis, excuse me, my y values that are positive need to go negative, and my y values that are negative need to go positive. Well, how do I do that, ladies and gentlemen? It's happening to y, so I'm going to multiply by a -1, okay? That's going to give me a negative on the outside of my grouping symbol. So I have y is equal to negative times the cubed root of x. Now I left a little space here for a reason, because you can see next it says we need a vertical stretch by a factor of 6. A vertical stretch is in the y direction, right? So I need to do that to y. So I'm going to multiply by 6. And that would give me that vertical stretch. So that's why I have that -6 on the outside. So the negative in green, sorry, I wrote it in green. I was trying to color code for you. That takes over the reflection, that negative piece. And the 6 takes care of that vertical stretch. Finally, we have a horizontal stretch by a factor of 2. A horizontal stretch by a factor of 2 means that I multiplied by 2 to the x value. Again, I multiplied by 2 to the x value. Well, remember, whatever we do to the x value is the opposite of what's happening inside, okay? So what that means is I actually multiplied by 1/2 inside. Or you could write it as y is equal to -6 times the cubed root of 0.5x. I believe that's how we've seen it on our homework, okay? Again, the opposite of multiplying by 1/2 inside would be multiplying by 2, because multiplying by 1/2 is really dividing by 2. The opposite operation, then we do the opposite of the inside. We multiply to x, and that gives us our value there. Lots of good problems that get difficult. Let's keep practicing. Okay, now it says use the graph to determine the original parent function and the transformations to it, and then give the new function, okay? Give the new function. Okay, the first thing that we want to recognize is we want to recognize what parent function that is. So that's the first step, the parent function. So I'll put PF for step 1. The parent function here is y is equal to x cubed. Okay, what I like to do then is I like to actually graph that. If I would make my table, I would say I'm just going to do 3 values, -1, 0, and 1. Okay, that's going to give me -1, 0, and 1 over here as well. So it's going to look something like this. Okay, again, I'm using my mouse at home on my computer, so forgive me, it's a little bit sloppier than I'd like. What I like to do then is I like to look right here and I like to say, okay, what's happening here at my origin? It looks like my origin here moved over to the right 1, and then it went down, oh dear. Let me try again here. Down 2. That's where I like to start, and then I like to just confirm. Did this point move to the right 2 and down 1? Okay. Or down, I'm sorry, to the right 1 and down 2? Well, to the right 1 is right here, and down 2 is right here. Let's check again. Did this one point right here move to the right 1 and down 2? To the right 1 and down 2. So the next thing I like to do on step 2 is I like to realize what is my actual description? What happened? What transformation happened? So in this case, the parent function went to the right 1 and down 2, okay? Then I like to use that description for step 3 to actually write what happened. Okay, remember, to the right 1, that is in our x direction. That means I added 1 to them, okay? I added 1, so I do the opposite operation inside the grouping symbol of that parent function. So I have y is equal to x minus 1 cubed. And then down 2 is on the outside. That means I subtracted 2. So minus 2 here, and I'm done with my function. So step 1, identify the parent function. Step 2, say what transformation happened. I like to write it out. And step 3, then rewrite the parent function as the transformed function. Let's try again. Okay. Again, step 1, let's recognize what parent function we have. Our parent function we have is x squared. I like to actually graph it. So I say, okay, and I'm just going to take 3 points. So -1, 0, and 1, 1, 0, and 1. And some of you might not need to graph it, but I just think you can see that transformation a little bit better. So here's our parent function in purple. Okay. Now I like to start at the origin. Okay. The origin right here is at 0, 0. Okay. I like to say, okay, what happened? How did I get to my next point? And that's step 2. We're describing what's happening. It looks like this point went to the right 3 and up 1. Let's confirm that the rest of the points did this. This point here, did that go to the right 3 and up 1? 1, 2, 3, up 1. It did. And then let's look at this point. Did this go to the right 3 and up 1? 1, 2, 3, up 1 right here. So the description is on number 2, I went to the right 3, up 1. Now I'm going to take what we know from before, and I'm going to write y is equal to, well, to the right 3 means I added 3 to the x's. Okay, so I'm going to say I need to do the opposite to the inside here of that grouping symbol. I'm going to subtract 3. And then up 1, well, up 1, that's the y value. So I added 1 to everything. So I'm going to put a +1 on the outside because anything that happens to the y is the same operation on the outside of the grouping symbol. And there is my function. I think this is here's our last one we're going to do. Or we might do 2 more, sorry. Okay, let's look at this one. We have a V. This one looks a little bit more difficult. Why? Because our V is upside down. So what that means is there was a reflection over the x-axis. Let's start with step 1 though. Y is equal to the absolute value of x. Okay, that's our parent function. I do like to make that table. -1, and I just do the 3 points that are centered around the origin. 1, 0, and 1. So I have 0, 0, 1, 1, -1, 1. Here's my V. Okay, so the first thing you can notice, ladies and gentlemen, is this parent function was reflected over the x-axis, okay? It was reflected over the x-axis. So I'm going to think about that. I'm going to write that down in step 2. How do I know it was reflected over the x-axis? My positive values here, okay, they all went to negative values. So what happened, ladies and gentlemen, is my y values were multiplied by a -1. I'm going to put a little dot here so we know it was multiplied by -1. So -1, 0, and -1. So I'll put that down here because that's where -1 looks like it might be. -1 right here, and it was flipped. Okay, next, let's see what happened. How did I get to way up here? So it looks like my origin was moved over to the right 1 and up 3. 1, 2, 3. Let's check my other points. Right here, this point, to the right 1, up 3, 1, 2, and 3. And to the right 1, up 3, 1, 2, and 3. Sorry, that got a little bit messy there with my mouse there. Okay, so let's write that down. Right 1 and up 3. Okay, so again, let's go ahead and let's talk about what happened here. If I go to the right 1, that's on my X value. If I go up 3, that's to my Y value. Okay, let's start writing what's going on. Step 3. Y is equal to, now first let's talk about this -1. That happened to the Y, so we're multiplying by a negative to that grouping symbol. Next, we had that addition of 1 to the X, which means I need to do the opposite inside that grouping symbol, so subtract 1. And then finally, I went up 3, so I'm going to add 3 to it. And there we have our function, ladies and gentlemen. Okay, I think I'm going to do one more with you, 1 second. All right, ladies and gentlemen, here is the last one that we're going to do for this learning target for the day, excuse me. Okay, so when we look at this one, the first one, again, step 1, we want to identify what is the parent function. Okay, so the parent function, this one looks a little strange, but it is because it was reflected over the y-axis. And I'm sorry, I'm getting in my statistics mode where I put a probability of x, parent function, PF. So my parent function in this one is actually y is equal to the cubed root of x. Okay, how did I know? Because my cubed root is that s-looking function. Okay, step 2. Oh, and sorry, within that step, remember, I do like to actually go ahead and graph it personally. We can't see it on here very well, but that's okay. We can kind of just make do. Okay, I just think it helps visually to see what's going on. Sorry. And I'm obviously not as good as the Desmos calculator. Okay. All right. Let's also write down the table. So we have -1, -1, 0, 0, and 1, 1. Okay, now we're in step 2 and figuring out what that transformation is. So you can see this S does not look the same as my S that I have. So what that means is we had a reflection, and we can look at this as a reflection over the x-axis. So what happened is the y values here. So my y value when it was positive is now negative. And then my 0, 0 stays the same, and my negative y value here is now positive. Okay. That's a reflection over the x-axis, and that's dealing with the y values, which is a multiplication of -1. Again, I'm figuring out step 2 right now, what transformation happened. So there's a reflection over the x-axis, okay? Next, I want to see, well, how did I get way over here? So it looks like I'm going to start at the origin. It looks like I moved to the, and here's my new origin. I moved to the left 1, 2 spaces, and down 1, 2, 3 spaces. Just let's check our other points here. Now remember, I'm working with the black graph here because I've already reflected it over the x-axis. So I want to check and see, did these points move to the left 2, down 3 as well? So if I go to the left, 1, 2, down 3, 1, 2, 3, I get there. And then let's take this point as well. To the left 2, 1, 2, down 3, 1, 2, 3. So again, a reflection over the x-axis. And then to the left 3, down, I lied, to the left 2, sorry guys, down 3. We know what the transformation is now. Now let's rewrite it. A reflection over the x-axis. Remember, we've already talked about that right here. That was multiplying the y by a -1. Anything that's happening to the y is the same operation to the outside of the grouping symbol, not inside. So that would be y is equal to negative. You could put a 1 there if you'd want, but just the cubed root of x. Next, I went left 2. Left 2 is happening to the x-axis. Going left 2 means I subtracted 2 to the x. Remember, whatever's happening to the x is the opposite of what's happening inside the grouping symbol. So let's rewrite it now. Y is equal to negative cubed root of x plus 2. Okay? Again, when I see what's happening inside, it's the opposite to x on the table. So I'm going backwards now. The table went to the left 2, minusing 2 to the x. So I add 2 inside that grouping symbol, that cubed root of x. And then finally, I went down 3. That's in the y direction. So that's outside the grouping symbol, -3. And there we go, guys. We're done. Way to go. It was a longer video. Appreciate your time, and I hope you guys have a wonderful day. Take care.